Good afternoon to everybody. I am Kavipriya, working as an assistant professor in Department of Chemistry. First of all, I heartily thank the management for giving this great opportunity. Now I am going to give a lecture on corrosion. Corrosion means it is a branch of electrochemistry. Okay. When the metal in pure form, that is, corrosion is defined as the gradual destruction or deterioration of metals in the course of their chemical and electrochemical reactions with the environment. That is, metals and alloys are in the native state, they are unstable because the metals and alloys undergo corrosion, the weight of the metal is reduced and their strength is lost and their metallic luster is also lost. Therefore, the corrosion is defined as gradual destruction or deterioration of metals in the presence of chemical and electrochemical reactions of the environment. Okay, and the causes of corrosion. Corrosion is the most serious problems in our modern society. The cost of corrosion in every year is enormous. That is, it runs into billions of dollars. What are the main causes of corrosions are, the metals occur in nature in native state. There are two states, one is native state and another one is combined state. Depending upon the nature of metal, they undergo corrosion. We have to calculate the rate of corrosion. First one is native state. Metals occur in, first one is native states. Metals occur in native or uncombined state. There is no reaction. There is non-reactive. These native metals, examples, gold, silver and platinum. These are noble metals. These are noble metals present in native state. These are metals are non-reactive with the environment. Therefore, there is no reaction takes place in the native state. But in the combined state, the second one is combined state. Except noble metals, that is, except noble metals, all other metals are reactive and reactive with the environment. They form stable compounds. They form stable compounds. These compounds are called ores and minerals. Their stable compounds are oxides, chlorides, sulfates and carbonates. The examples of oxides are Fe2O3, iron oxide, okay, and chlorides, that is zinc sulfide, and carbonate, calcium carbonate, and lead oxide, PbO. These are the some examples of ores and minerals. Okay, therefore, except noble metals, all other metals are occur in nature in the combined state. They form stable compounds called ores and minerals. Now, we have discussed how and why the corrosion takes place. How the corrosion takes place in a metal. How and why corrosion takes place. Okay, now we see how and why corrosion takes place. When the metal in pure form, that is, this is the metal in the higher energy state. Higher energy state, they undergo oxidation. That is, the corrosion takes place. This is the oxidation process. Do you have any idea about oxidation? Which reaction is known as oxidation reaction?
Addition of oxygen and removal of hydrogen is known as oxidation.
Okay, correct. Which reaction is known as reduction reaction?
And reaction which involves addition of hydrogen and removal of oxygen and loss of electron is known as reduction reaction.
Okay, very good. That is oxidation reaction means addition of oxygen or removal of hydrogen, and the reverse is the reduction process. Therefore, the metals in higher energy state undergo oxidation reaction. They form the stable compound, that is the metallic compound. They form the metallic compound. They form the metallic compound in lower energy state. This is the reverse process. That is the metal in lower energy state. The reverse one is reduction reaction. This is the basic mechanism for how and why corrosion occurs. That is, all these compounds are extracted from ores. They undergo corrosion in the excited state. That is, the metal is converted into its compound. This is the reduction process. The reverse is known as reduction process, and the oxidation process is due to corrosion. Okay. Therefore, the metals in different various form will be exposed to the environment. That is, the environment means the atmospheric gases, moisture, and other chemicals. These are influence the corrosion. Some other chemicals, they are influence the corrosion. Therefore, the exposed metal undergo corrosion, the weight of the metal is reduced and their strength is also lost. Okay. And some other forms of corrosions are the deterioration of, except not only metals and their plastics and other materials, woods. These are also the degradation of corrosion. And the general example, that is the common example of corrosion, is rusting of iron. The common example of corrosion is rusting of iron. We know that the iron exposed to moisture or air, they form the rust. That is Fe2O3 is nothing but rusting of iron. Okay. The equation is this is a common example of corrosion. This is nothing but rust. That is, when metal undergo corrosion, that is oxidation process, the rusting of iron takes place. That is, iron react with moisture and oxygen, dissolved oxygen, they form rust. These are the how and why corrosion takes place in metal state. And now we discuss about the effects and consequences of corrosion. Effects of corrosion. First one is, the metal undergo oxidation, corrosion takes place. That is, in dry corrosion, the metals in above the metal, the dry layer of the corrosion product is formed. Therefore, due to the formation of the corrosion product in the machinery, the corrosion product in machinery, they affect the efficiency of the machine, and the product is contaminated, and the plants get failure due to corrosion. And the time is lost for the arrangement of equipments is very, very difficult. And we know that the Titanic ship, that is sank in the sea because due to the fact of corrosion. Okay, and the Silver Bridge collapse in West Virginia is also due to the fact of corrosion. These are the some important and familiar effects of corrosion. Okay, and the second one is some other factors that influence the corrosion. That is, the rate of corrosion increases because it depends upon the electrochemistry part, that is anodic and cathodic part. These are the some factors that influence the corrosion, and the corrosion of the product is contaminated very, very easily. And another one is cost of corrosion. It is one of the most serious problems in our modern society. The corrosion study reported that the annual corrosion cost ranged approximately from 1 to 5% of the gross national product. So it is the very most serious problem which cannot be prevented but can be controlled. Okay, and the cost of corrosion study reported that 5% to 1 to 5% of the gross national product of each nation is due to the loss of corrosion. And next one is types of corrosion. Types of corrosion. Depending upon the environment, the corrosion are classified into two types. One is dry corrosion or chemical corrosion, and another one is wet corrosion or electrochemical corrosion. You see one by one. First one is dry corrosion. Dry corrosion is nothing but when the metal is exposed to the environment, they undergo corrosion because it reacts with the environmental gases like oxygen, sulfur, hydrogen sulfide, hydrogen, etc. They form the dry layer of the corrosion product. In the metal, they form dry layer of the corrosion product. They form the dry layer. This layer is nothing but the protective film. This is known as the protective film. Once the protective film is formed, further corrosion will be prevented. This is the dry or chemical corrosion. Therefore, the metal is exposed to the environment, they react with the gases, that is atmospheric gases like hydrogen, oxygen, sulfur dioxide. They form the dry layer of the corrosion product. The corrosion product is nothing but the protective film. Once protective film is formed, the further corrosion arrests. And next one is wet or electrochemical corrosion. Depending upon the nature, that is the metal takes place when two similar or dissimilar metals react with each other in an aqueous solution. They form wet or electrochemical corrosion. They follow the two mechanisms. First one is at cathode and anode. Electrochemical reaction takes place means the metal or the rod connected with the cathode and anodic cell in the presence of an aqueous solution. Any electrolyte solution, then only the electrolysis process takes place. In this case, in electrochemical or dry corrosion, first at anodic side, that is the metal. Oxidation means addition of oxygen. In electronic concept, that is removal of electrons, that is M gives M2 plus 2E minus in the anodic part. And at cathode, what reaction takes place means at cathode the liberated electrons are accepted by the atmospheric gases like oxygen. For example, the oxygen accept electron from anodic part, they form metal oxide layer. This is metal oxide layer. Now we discuss about detail in wet or electrochemical corrosion. That is when two metals are in contact with each other in presence of an aqueous solution. That is the electrolysis process takes place means the metal connected with cathode and anodic compartment with the liberate of electrons in the electrolytic solution. In a wet or electrochemical corrosion, that is when two metals are in contact with each other in presence of an aqueous solution, that is the liberation and the acceptance of electrons takes place. Therefore, first one is at anode. For a metal, the anodic reaction takes place with the liberation of electrons, that is metal release electron, it forms metal ion, and anodic part the electron release takes place. At cathodic part it depends upon the two types of environment. First one is in acidic environment and basic environment. It depends upon the two environment. One is acidic and another one is basic environment. In acidic environment, that is the liberated electrons in anodic part accepted a pair of electrons in the liberation of hydrogens. That is in acidic environment the acids like HCl, H2S liberates electrons and hydrochloric acid. That is the acids like HCl, H2S and H2SO4. Sorry, this is H2SO4 liberates hydrogens in acidic environment. That is what reaction takes place means that is the formation of hydroxide ion. That is the liberated electrons accept oxygen in presence of moisture medium, the formation of hydroxide ion. And in neutral environment, that is neutral, basic and neutral, that is pH 14, in neutral environment in presence of water, the reaction is, the combined reaction is, that is metal in neutral environment means the presence of water, that is H plus and OH minus ion. Therefore in basic and neutral environment there is the formation of oxide ions, hydroxide ions, that is M2 plus and OH minus gives 2OH minus, the liberation of hydroxide ion. Therefore in metal electrochemical corrosion, that is the anodic part, the liberation of electrons, the formation of metal ions, and cathodic part it accepts electron with the dissolved oxygen, they form hydroxide ion formation. The first one is known as the acidic environment, release of hydrogen is known as hydrogen evaluation type corrosion, and another one is formation of hydroxide ion. Example, in the best example is rusting of iron. Generally the iron, that is we represented metal as M, for particular that is mild steel and carbon steel is nothing but the composition of iron. That is in acidic environment the hydrogen evaluation type corrosion takes place. We see one by one, that is hydrogen evaluation type corrosion. This is nothing but the acidic environment release hydrogen. Hydrogen evaluation type corrosion is known as in the EMF series, that is in EMF series the metals above the hydrogen they form corroded vigorously. When metal in contact with the acidic gases like HCl, it liberates electron, that is Fe2 plus and 2E minus at cathode, at anode, and cathode is the liberation of electrons with the oxygen. At cathodic part the same reaction, the oxygen accept electrons from anodic part, they form the hydroxide ion. This is nothing but the hydrogen evaluation type corrosion. And another one is formation of hydroxide ion. Formation of hydroxide ion. That is in hydrogen evaluation type and the formation of hydroxide ion, the net reaction is Fe2 plus combined with these hydroxide, they form FeOH twice. This is nothing but the rust. If excess of oxygen is present in the environment, it undergoes further oxidation. They form FeOH thrice, is nothing but rust. This is hydrogen evaluation type corrosion and formation of hydroxide ion formation of hydroxide ion corrosion. The net reaction is the wet or electrochemical corrosion. These types of corrosion, that is dry or chemical corrosion and wet or electrochemical corrosion, are represented by a small corrosion triangle. This is metal. Consider this is a metal. When electrolytic process takes place means the cathode, anode and the electrolyte solution. That is the types of corrosion, dry or chemical corrosion and wet or electrochemical corrosion are represented by a corrosion triangle. This is corrosion triangle. Corrosion triangle. When steel undergo corrosion, oxygen, that is air and moisture are necessary. Air and moisture are necessary. Remove air, no corrosion takes place, and remove moisture, no corrosion takes place. This is represented by a corrosion triangle. There are different forms of corrosion. Now we discussed about one by one. First one is galvanic corrosion. Galvanic corrosion is nothing but when two dissimilar metals are in contact with each other in an aqueous solution. Say example, sodium hydroxide is aqueous solution, electrolyte. What reaction takes place means when two dissimilar metals, I take two dissimilar metals, zinc and iron, in an electrolytic solution. This is electrolyte. Sodium chloride. Say example, sodium chloride is an electrolyte. What reaction takes place means zinc has high negative electrode potential. That is, in EMF series, zinc has high electrode potential, that is minus 0.76, and iron, this is minus 0.44. Zinc metal has high negative reduction potential minus 0.76 and iron has 0.44. Compare zinc and iron metal. Zinc corrode more vigorously compared to iron because they have higher reduction electrode potential, get corroded fastly compared to the other one. Therefore, zinc protects the iron. Therefore, zinc is also known as sacrificial anode. Because zinc protects iron, because depending upon the EMF series value, high reduction potential corrode vigorously compared to the other one. That is another metal. Therefore, zinc protects the iron. This is known as sacrificial anode. Zinc is behave like sacrificial anode. And another one example is copper and iron. Two dissimilar metals are in contact with electrolyte, sodium chloride. The copper has EMF series, the electrode potential is 3.44 and the iron electrode potential EMF series is minus 0.44. This is plus value. In the compare these cases, iron undergo corrosion fastly compared to copper because they are higher reduction potential. This type of corrosion, that is galvanic corrosion, takes place in two dissimilar metals depending upon the position in the EMF series. Second form of corrosion is differential aeration corrosion. Differential aeration corrosion. Consider a zinc rod dipped in the electrolytic solution. I will take the electrolytic solution is sodium chloride and zinc chloride. It is partially immersed in the electrolytic solution, that is zinc rod. This is zinc rod immersed in the electrolytic solution. Consider a zinc rod immersed in an electrolytic solution. That electrolytic solution is nothing but sodium chloride and zinc chloride. In this setup, that is cell setup, what reaction takes place? This is oxygen rich area. Zinc rod immersed in a sodium chloride solution. This the above the water line is a cathodic part, and the bottom level dipped in a sodium chloride solution is a oxygen poor area. It acts as anode. This part acts as anode. We know that the mechanism of corrosion, what reaction takes place at anodic part? Oxidation, that is liberation of electron takes place. Zinc undergo oxidation, it liberates electrons. They form zinc 2 plus and 2e minus in anodic part, and the cathodic part is the formation of hydroxide ion. At cathodic part, the oxygen accepts electron from the anodic part with the moisture. They form hydroxide ion. This type of corrosion is known as differential aeration corrosion, and they divided into some subdivision. Pitting corrosion. First one is pitting corrosion, and second one is crevice corrosion. Third one is pipeline corrosion. And fourth one is intergranular corrosion. And fifth one is corrosion on wire fence. You see one by one. Pitting corrosion. Pitting corrosion takes place means when the metal are in contact with, consider this is a metal, contact with direct contact of the environment. This is the cathodic part. Environmental gases. The metal is placed in direct contact with the environment. This is a water drop or any alkaline solution. Alkaline solution in a metallic part. This is acts as anode. Consider iron metal. I take a water drop in the iron surface. What reaction takes place? The water droplet area is the anodic part. It is an oxygen poor area. Corrosion mechanism is nothing but the oxygen poor area undergoes corrosion fastly compared to the rest area, that is the cathodic part. This is the cathodic part. The metal surface is a cathodic part, and we take water droplet in the metal surface, acts as anode. It is oxygen poor area. It undergo corrosion, and they form a hole. In the metal surface. This is known as pits. Pits or holes. This type of corrosion is known as pitting corrosion. And second one is crevice corrosion. Crevice corrosion. Second subdivision in differential aeration corrosion is crevice corrosion. Crevice corrosion is nothing but Consider two dissimilar metals. Consider a crevice is nothing but a space. Crevice between two metals with the aqueous solution. This is the anodic part, and the rivet is nothing but cathode. Consider a crevice between two metallic rods in aqueous solution. The oxygen poor area is known as anode. At anode, the oxygen is very poor and it undergo corrosion. But the rest part, that is the cathode, it is an oxygen rich area. It does not undergo corrosion. This type of corrosion is known as crevice corrosion. And another one is pipeline corrosion. Consider a buried pipeline and the two type of soils. Consider a pipeline immersed in two type of soil. One is clay and another one is soil. This is clay and this is soil. We know that clay is a less aerated area. That is, this area, clay, oxygen is a poor area, and soil, we know that this is a oxygen rich area. That is, this is more aerated. Now, what type of reaction takes place? Tell me. That is, in clay, this is oxygen poor area, that is less aerated area. It undergo corrosion fastly compared to the soil. This type of corrosion takes place in pipeline corrosion. That is, the clay, less aerated area, it undergo oxidation, and soil, the areas are more aerated, it does not undergo corrosion. And the fourth one is intergranular corrosion. Intergranular corrosion takes place in the metal boundaries. That is, the boundaries, some impurities are present. Some impurities are present in the metal boundaries. This is that is the gap. This is the oxygen poor area acts as anode, and the rest part acts as cathode. All types of corrosion takes place the same mechanism. That is, oxygen is poor means anodic reaction takes place. That is the liberation of electrons, and cathodic means oxygen is rich area. It does not undergo corrosion. Therefore, the metal in intergranular corrosion means it explained in the boundaries. And last one is corrosion on wire fence. Consider a wire fence. This is a wire fence. You easily say that. Consider a wire fence. This is the wire cross the fence is called which part? Oxygen poor area. This is oxygen poor area. This is nothing but anode, and the rest part of the wire fence acts as cathode. Therefore, in anodic part, that is across the wire fence, it acts as anode. This is oxygen poor area, and the remaining part, the rest part is known as cathode. It does not undergo corrosion. This type of corrosion is known as corrosion on wire fence. These are the different forms of corrosion. One is pitting corrosion, another one is crevice corrosion and pipeline corrosion. Consider a buried pipeline in two types of soils, and fourth one is intergranular corrosion, and last one is corrosion on wire fence. Another heading is factors influencing the corrosion rate. Factors influencing the corrosion rate. First factor is, it depends upon the nature of the metal. And second one is nature of the environment. These are the two important factors that influence the corrosion rate. First one is nature of the metal. Nature of the metal depend upon the position of the EMF series. Position in EMF series. EMF series is nothing but electromotive force. Nature of the metal means it depends upon the position of the series. That is, when EMF series, the metals above the hydrogen corroded fastly compared to the other metals. Therefore, depending upon the nature of the metal in position of the series, that is, greater is the difference in EMF series, greater is the corrosion rate. And second one is, this is the first point, position in EMF series and relative areas of cathode and anode. Relative areas of cathode and anode. Relative areas, that is, anode acts as a oxygen poor area in all type of mechanism, and cathode acts as oxygen rich area. In anodic part, oxygen poor area, it undergo corrosion compared to the cathodic area. Therefore, the relative areas depend upon the factors influencing the corrosion rate. And third one is purity. Purity of the metal. Purity of the metal. When the pure zinc rod has 99.9% purity, the corrosion rate is 1%. Purity influences the corrosion rate. That is, the pure metal does not undergo corrosion. Some impurities present on the metal, they form the corrosion and increase the corrosion rate. And another one is over voltage. That is, corrosion rate inversely proportional to the over voltage or over potential. Over potential or over voltage high means it is inversely proportional to the corrosion rate. And these are the factors depend upon the nature of the metal. And second one is nature of the environment. Nature of the environment, generally environment means what? Temperature, gases, these are the environment. And nature of the environment, if we rise the temperature, what takes place? Corrosion rate increases, that is CR increases. Therefore, we rise the temperature, the corrosion rate increases. And second one, oxygen and moisture is nothing but humidity. Humidity of the environment increases, corrosion rate increases. And the presence of corrosive gases. The presence of corrosive gases such as acidic gases like HCl, H2S and sulfuric acid, they liberate hydrogen. They form hydrogen evaluation type corrosion. These corrosive gases form hydrogen evaluation type corrosion. And corrosion in suspended particles. Suspended particles, that is sodium chloride NaCl and NH4 ammonium sulfate. These are strong and weak electrolytes immersed in the moisture, that is environment, that is the electrolyte cause the suspended particles, the corrosion rate increases. And another one is pH. The important one is effect of pH. We know that the pH scale, we know that the water level of pH 7 means no corrosion takes place. Normally acidic medium unless basic medium forms corrosion. That is pH less than 7, acid. Normally acidic medium favors corrosion compared to basic medium. We discussed about the types of corrosion and different forms of corrosion and some factors influencing the corrosion. How to calculate the corrosion rate? Calculation of corrosion rate, CR, is nothing but is expressed in MDD and MM. Corrosion rate is calculated, the metal lost per unit time is called corrosion rate. It is expressed in milligram per square per day and millimeter per year, and MPY is nothing but mils per year. These are the three terms we have to calculate the corrosion rate. And the next one is how to prevent. The final is how to prevent and control corrosion. Prevention and control of corrosion. Nature of metal and nature of environment. These are the important factors that influence corrosion, and depending upon the factors influence the corrosion rate, we have to control and prevention of corrosion. First one is by alloying. First method is by alloying. Normally iron gets corroded compared to other metals. By applying the alloying method, that is iron combined with nickel, chromium. The iron nickel chromium alloy is known as stainless steel. For avoiding the corrosion, the alloying application takes place. Iron, nickel, chromium. These metals combine form a stainless steel. Because of the stainless steel application, the corrosion prevention takes place. And second one is, depending upon the environment, de-aeration. How to remove the de-aeration? By the application of silica gel, some silica gel and ammonia. Silica gel or ammonia, alumina. We are adding silica gel or alumina to the environment, de-aeration takes place. This de-aeration takes place means corrosion can be prevented. And third one is presence of inhibitors. Inhibitor is nothing but a substance which can prevent corrosion and reduce the corrosion rate. There are some types of inhibitors: cathodic inhibitor, anodic inhibitor, and neutral inhibitors. Depending upon the type of inhibitor, corrosion can be prevented. Cathodic inhibitor means the cations are liberated. Example: silicates, nitrates, phosphates, phosphonates. These are the types of inhibitors. And the zinc sulfate is taken means it liberates Zn2 plus and SO4 2 minus. This is the cathodic inhibitor. These types of inhibitors avoid prevention and corrosion control methods. These are the methods, important methods for preventing and control of corrosion. First one is alloying, modifying the alloying environment, and de-aeration, adding silica gel and alumina, and the inhibitors, cathodic inhibitor, anodic inhibitor, neutral inhibitor. Depending upon the type of inhibitor, some type of corrosion should be avoided. Now we recall from first one. Corrosion is nothing but destruction or deterioration of metal in the presence of chemical or electrochemical reactions with the environment. That is, the corrosion takes place means the metal get reduced and their metallic luster, the property of the metal, the luster property, malleability, ductility, these are reduced. And the corroded metal is unsuitable for any construction work and engineering work, etc. And causes of corrosion. There are two types of state, native state and combined state. In native state, the metals are in pure form, that is noble metals. We see the example, silver, platinum, gold are noble metals. These are used in ornaments and surgical instruments. These noble metals are used in our daily use ornaments and surgical instruments. And another one is native and combined state. Combined state is nothing but metal, they form a stable form of compounds, that is ores or minerals. And why, how corrosion takes place means metal liberates electrons, that is oxidation reaction takes place means corrosion takes place. And the reverse process is reduction, that is the ore is converted into their metal. And types of corrosion, there are two types, dry or chemical corrosion and wet or electrochemical corrosion. Dry corrosion means when the metal is exposed to the environment, that is the metal, we already discussed types. One is dry chemical corrosion, wet or electrochemical corrosion. All types of reaction, anodic part, oxygen, poor area, anodic part, that is liberation of electron takes place, and cathodic part, that is acceptance of electrons from anodic to cathodic part, formation of hydroxide ion. And dry corrosion means metal oxide layer formed. That layer is nothing but protective film. Once protective film formed, further corrosion avoided. Wet or electrochemical corrosion is a two type, hydrogen evaluation type corrosion and hydroxide ion formation. And we discussed about the factors influencing the corrosion rate, that is the temperature, pressure, humidity, pH. These are the some factors that influence the corrosion, and this is the depend upon the metal and the environment. And prevention and corrosion of control by alloying, de-aeration, and presence of inhibitors. Different types of inhibitors, depending upon the inhibitors we chosen, we avoid the corrosion. And all types of electrochemical corrosion are represented by a corrosion triangle. Remove air means no corrosion takes place, and remove moisture, no corrosion takes place. In this unit, we have discussed about the corrosion and their cause and their causes and types of corrosion, different forms of corrosion, and how to prevent and control the corrosion.